Hi and welcome back to my channel. My name is Adrian Cidre and in this tutorial I will show you how to use the rpostgis package, which I am currently the maintainer. So this package provides an interface between R and PostGIS-enabled PostgreSQL database, and it's used to transparently transfer spatial data. So in this case we will have an spatial data which is denominated PostGIS, and there we can store our spatial data, and thanks to this package we can read it and write it from R. So we will see an overview of how to use this package. But first of all we need to install the necessary software, which is this PostgreSQL and PostGIS. So first you will need to download pgadmin, which is used as the interface to interact with PostgreSQL. So if you go to pgadmin.org, you can go to this download button. And here you will see the different URLs to download depending on your operating system. In my case I'm Windows, so I will go to this link. And here you have the latest versions. So in my case I will download the latest one and I will install it because I want also to update it. So I will click here in the executable and it will start downloading it. Once it's downloaded, we can open the executable and we will go through the installation. So I will hit install, and in the meantime we can download PostgreSQL. So you can find download PostgreSQL in Google and you will open the first URL. And here you again have the different URLs for the different operating systems. In my case again I will go to Windows, and here you have the different versions of PostgreSQL. I will download the latest version and I will go here to download the installer. And the latest version for Windows is in this button here. So I will click on it and it will start the download. Okay, now I have finished the installation of pgadmin 4 and now we will go throughout the installation of PostgreSQL. So we will go to next, I will go again to next, I will install all of these programs, I will go next, next, next again, and now it will start the installation. So once the installation is finished, you will see this new window, the Stack Builder. And here you will have to select the installation that you are installing the software for. And in my case, I'm installing it for PostgreSQL 17, which is the latest version that we have installed right now. And here you see the option for PostgreSQL 16 because it's another version that I have already installed in my computer, but I had it already previously. And you can also do it for a remote server. In this case, I will use the Postgres 17 on the port 5433 in my case. So now we will go to next. And here, very important, we need to go to Spatial Extensions and select the PostGIS extension. And this will install it in our computer for this PostgreSQL 17 version. So now I will go to next, next, next again. And I have this window now from PostGIS. So here you have the public license of PostGIS. So I will hit that I agree. And here you have different options that you can select. You can also select to create a spatial database by default. I will check this one. I will go to next, next again. And here you must select a username, which is by default Postgres. I will leave it as it is. And we need also to check one password. So I will write something here. And now I will go to next. And this is the name of the sample database that we checked before. So I will leave it as it is. And I will hit install again. Okay, it looks like we are done here. So I will close and we will finish the installation. And now we are ready to go to R. Okay, since this video is already too long, I already brought all the code and we will go through it. So first I will start loading all this code that we have here and I will explain it in a moment. So first we are loading a series of packages that we have all of them here. And first we will load some data that we will play with when we are in PostGIS. So first I will load an study area, in this case the boundaries of Slovakia, which I use the Gisco R package to download them. Then I'm getting a raster with the get elef raster, and this is a digital elevation model for Slovakia and with a thumb level of 8. Since this function returns a raster layer from the raster package, we need to transform it to the Terra package with the rast function. And finally, I project it to the same coordinate reference system as the country borders. Then I'm creating terrain rasters such as the slope and the aspect with the function terrain from the Terra package, and then I'm stacking all the bands in a single layer. So if I print this in the console, you will see that it's a spat raster with 3 layers: the digital elevation model, the slope, and the aspect. And here I'm changing the names to these ones. And now I'm creating some points. So I will run these lines of code and I will print it in the console. So here we have a series of points, in total 5,000, and they are all within the study area. So we can visualize it by using the plot function, and I will write terrain SR, and I will plot the digital elevation model. And we can also use plot to add the Slovakia SF, and I will use add equals to true, and then I will say color equal to NA. And if I make this a bit bigger, there we have it, the digital elevation model, the borders of the country, and I can also use plot to points SF, and I will say add equal to true. So there we see that we have all of these points within the boundaries of Slovakia. And now I will use the extract function to extract the values of the terrain raster on each of the points. So let me print it in the console, terrain table, and I will show you just the first row. So here we have for each of the points the value of the digital elevation model, the value of the slope model, and the value of the aspect. And then we will bind the columns with the points, and we will rename the geometry to this name. So here we have again our 5,000 points, but now we added all of these attributes. So I will print it again, and now we have stored it in this new object. So up to here we have 3 different objects. We have Slovakia SF, which is a polygon with the country boundaries. We have terrain SR, which is a raster with 3 bands, the digital elevation model, the slope, and the aspect. And finally we have terrain SF, which are 5,000 random points with terrain values. Alright, so now what we will do is to open PGAdmin, which is the first software that we installed. And I will bring it to this screen right here, and this is the graphical interface. So here under servers we can hit in this arrow, and you will see the different installations of PostgreSQL that you have installed in your computer. Before I was working with PostgreSQL 16, but now I installed the latest version. And here you will be asked for a password, and this is the password that we created previously in the installation. So I will write it. Oops. And if you don't want to write it other times, you can just hit in save password and you don't will be prompted to write it again. So I will hit in OK. And now here you have the different databases that you have inside this installation of PostgreSQL. So I have the Postgres database, which is a basic database, and this one, the PostGIS 35 sample, which is the sample that we created with the PostGIS installation. So here, if I see all these options, you will see here the extensions. And here you will see that you have the extension of PostGIS and other PostGIS extensions already installed. But if you go to this one and you go under extensions, you will see that you only have one. So here to this database, you wouldn't be able to write rasters or vectorial objects. Alright, so once we saw this, I will go back to R. And first of all, I will show you this keyring package, which is very nice to hide our passwords. So if I use this key list function, you will see the different keys that I have stored in my computer. So I have these two. And you can create a new one using this key set with value, and you first set your service, your username, and then your password. So if I use this and now I see my list, you see that one has been added with the service my service and with the username my username. So if I use this key get function and I use my service and my username, it will retrieve my secret password. But this is secret because we can use just this function as you see it here, so I don't need to write here the password and you don't need to see it. And if we want to delete one of these password or keys that we created, we can use the key delete function and say my service, my username, and now I will see my list again and I have only the two original ones. Alright, so now the first thing that you need to do when you want to interact with PostgreSQL is to create a connection. Actually, this is what you do when you want to connect with any database. In this case, for a PostgreSQL database, we use this package, rpostgis, and we use the dbconnect function. And here we have a series of arguments. First, the driver, which is Postgres, which comes also from the same package. Then we need to say which is the host. In this case is our local host. We are not in a remote server. Then the DB name, the database name. Here I called it test rpostgis. Then the user, remember we created an user which was called or named Postgres. The port, which I had 5432, but remember this port is for my PostgreSQL 16 version. If I want to use the latest version, I should use this other port. And finally, my password. So I will execute this line of code and you see that I received an error because this database doesn't exist. So in order to use this function, we need to first create the database from pgadmin itself. So I will open it again, and here under databases, I will use my right button, create database, and I will call it test rpostgis. And the rest of the things, I think I will leave them by default. Or if I go here to definition, let me find it. Never mind, I will just create it like this. And now we can go under extensions and we can go to create extension. And if we want, we can find here PostGIS and we can install the PostGIS extension. But I won't do it like this because we can do it from R. So now we just created the database. I will go back to R, and now if I use this function, you see that I don't receive the error. And we just created this connection object, which is a PQ connection to this database in localhost 5433. Alright, so now if we want to install the PostGIS extension, we can use this function pgpostgis, which comes from the rpostgis package, and we need to specify first the connection, And this is something that you see in all of the functions of the package. The first argument is always the connection. And then we are also specifying that we want also the raster extension. So I will hit Control Enter, and you see that it's creating the PostGIS extension with this version, installing raster extension with this version, and the query was executed. Now we can go to pgadmin, and here if I go to test rpostgis and I refresh this, you will see that now these extensions are installed. Alright, so now we will create an schema. And what is an schema? I like to think about them as subfolders of my database. So with this db schema function, we will create an schema called my first schema in my connection. So I will use Control Enter, and you see that it used this code to create the schema. So now if I go here again to pgadmin, you will see this window here, or this option here, these schemas, and you see that we have by default one that is called public and the other one that we created, my first schema. And if we open it, you will see many other different options, but probably the most important one is here under tables. And the tables that we create or that we write into the database will be stored under these tables options. So I will minimize it again. And now if we want to delete an schema, we can use the db-drop function, give it a name, and say that we want to delete an schema. Because with this function, we can also delete a table, schema, a view, or a materialized view. So I will execute it, and you see that the query was executed without a problem. So now I will create another schema, which I will call Slovakia. So I will execute it, and you see that the query was executed properly. We have now these two functions, pglistgeom and pglistrast, we can use in our connection to see the different tables that we have in the database, but you see that it's empty. So we will write some tables now. And the first table that we will write is it will be vectorial data, it will be the boundaries of Slovakia, and to do so we use the pgWriteGeom function. First we give the connection, secondly we give it a name, I will call it Slovakia boundaries. We tell with the data.obj argument the object that we want to save into the database, and in the case that we want to overwrite it. In this case, I will comment out this and I will execute it. And you see that it prepared the table, inserted it, and it was inserted under public schema and Slovakia boundaries. And this is important because you will see that by default it will use always the public schema unless we tell it a different thing. And now also if you want to try to execute this code again, you will see that it will add them on the top of the previous table. So if we want to overwrite it, we should use the overwrite equals to true. Because now if I use the pggetGeom function, which is the one that we use to read from the database into R, I will execute it, you will see that we get an object with two geometries. And if I execute this again, and I read it back, you will see that we are adding the data on top of the previous one. So remember, if you want to overwrite an object, you need to use the overwrite function, or sorry, the overwrite argument. Now if I execute it and I read it back into R, now we have our object back, only with one row for the country. Okay, so now if we want to write it in a different schema, in the name argument, we need to specify a character vector of length 2. First, the name of the schema, in this case Slovakia, remember we created this schema before. And secondly, the name of the table, in this case again Slovakia boundaries, and then the data object. So I will execute it, and now with the pggetGeom function, we use the same structure. we use the connection, and in the name a character of length 2. So I will execute it, and here we have our object back. And now we can see how this looks like in pgadmin. So here I will refresh the tables, I will open them, and yeah, I need to refresh this, and I should go to Slovakia tables, and here we have the Slovakia boundaries table, and we can see the columns and also other different options. Okay, so now we will see how to use different clauses to insert data. So here I will write now the terrain SF, which I will remind you is this object with 5,000 different points with the digital elevation model, slope, and aspect values. So we will use the pgBrightGeom function. We created the new table, and the data was inserted into Slovakia terrain points. So now we can read them back, we can read all the data, or we can use different SQL clauses. So here we will select all the points, but we will add this clause where the slope is greater than 10 and the aspect is greater than 337.5 or the aspect is lower than 22.5. This is north orientation, and we want to order them by the DEM column and by descending. So I will execute this, and here we have them. We have a total of 76 different features, and you see that the aspect is always within these values, so greater than 337 and lower than 22. You can see it here, and you can see that they are ordered by the digital elevation model in descending order. So here we have the greatest and here the lowest. And here you can use any other clause that you want from the SQL language. Okay, now in the step 6 we will see how to insert and read raster. And to do so we use the pgBrightRast function, and again the connection, the name, so Slovakia schema, terrain raster name, and the raster that we want to insert, in this case terrain SR. So I will execute it, it will split the data into blocks, so it will be easier to insert the data, but you will see that the rasters will take a longer time than vectorial data. Alright, now it's finished. You see that it took about 1 minute, which is quite a lot of time for writing 3 rasters. But yeah, we have it like that. And now if we want to read the table from the database into R, we can use the pggetRast function, and we just need to specify the connection and the name. So if I execute it, you see that by default it will read only one band. So in this case the first one, which is the digital elevation model. If we want all the bands, we can use the argument bands equal to true, as you see it here. So I will execute it, you will see that it's reading the 3 bands. And in the meantime, I will show you also how to, let's say, read bands 1 and 3. So if you want to do that, you can write a vector with the band 1 and the band number 3. So here you see the digital elevation model, slope, and aspect. And if I use the function like this, we are reading 2 bands, and they should be the digital elevation model and the aspect. And there it is. Okay, so this was a brief introduction to this package. I hope you liked it and that you want to try to use it. But remember, the last thing that you need to do always when you connect to a database is to disconnect from it. And we use the db-disconnect function with the connection argument. And now we are disconnected. And once we are disconnected, we cannot interact with it anymore. If I try to use this function, you will see this error. Okay, So this was everything. I hope you liked it, and if you liked it, I hope you will hit the like button and subscribe to my channel for more videos. And I will see you in the next time.